All right, finishing up 6.0, power rules. I think last we saw we were doing powers to a power and negative powers and flipping things and doing all that fun jazz. All right, what do we do if we have a fraction? Can you have fractions as a power? Yes, sir. In fact, just so you guys know, b to the 1/2 is the same thing as square root of b. All right. Square root of b is the same thing as b to the 1/2, which makes sense because of our rule. If I do b to the 1/2 to the 2, that's the same thing as squaring a square root. 2 times a half is 1. So they cancel each other out. That's one way I can solve things with exponents, is by using the fractional exponents. Reason? I don't know. Because it is. All right, let's do some examples. Or see another piece of the rule. Uh-oh. Sorry, people on the internet machine. So, if I see something with a fraction and there's multiple numbers, I'm rooting it and then I'm squaring it, or squaring it and then rooting it. Okay? Good news for you is, well, I'll show you when we get to the calculator part. I'll show you how to do it on the calculator. Let's do some examples without calculator. I'm not going to make you do this on the test because I'm letting you use a calculator on the test, and that'd be kind of tough for me to say, hey, everyone put away your calculator for this one. But I just want to show you that this is possible. This is saying what number times itself 3 times is equal to 125. Well, what number times itself 3 times is 125? 5. Okay? 5. Or, that's cube root of 125. Okay? On this beast, this is actually something, if you go on and take pre-calc, it comes up a lot because there's non-calculator tests on that one. What you do with this 81 is you break it down. How many 3's make up 81? 4 of them. So this is the same thing as 3 to the 4th to the 3/4. Okay? Again, this will not be tested. This is a good number theory thing. What do I do with my exponents for a power to a power? You multiply them, right? So what's 4 times 3/4? 4's cancel, right? It's 3 to the 3rd. 3 to the 3rd is 27. Okay? So I'm not going to spend a lot of time on this. I just wanted to show you that that's a way. If you change your base, you can do complex exponents without using your calculator. Make sure you have your calculator on you. Make sure that you know how to put in these keystrokes and practice it, right? Because remember, when's a bad time to ask me how to plug in your calculator? The day of the test is a bad time to ask me how to plug in your calculator. When's a good time to ask how to plug stuff in your calculator? Ooh, that would, you know what? 100%. That's a 10 out of 10 answer, young man. I couldn't think, I don't even know if you're patronizing me, but I can't think of a better answer than that. That's fine. All right. In your calculator, I just want to make sure that you guys can do this accurately. So your keystrokes to enter that in, you could square root it, but let's get used to using fractional powers. So you're going to hit the 5 button. Caret key. Now what would happen if I hit 5 caret key 1 divided by 2 on my calculator? What will that give me as an answer? That'll give you what? Probably 2.5? Right? Because what's it going to do? It's doing 5 to the 1st and then dividing by 2. Right? What do you need to do with fractions? I know a lot of your calculators move it up. But what do we need to do with that fraction? Put in parentheses, right? Look, I mean, I'll even do this is fancy. You need to put that in parentheses. So make sure you're getting a decimal of some sort, probably about 2.2 2.3? All right. There will be a test question, a homework question that makes you plug this in using your calculator. And you'd be surprised at how often little mistakes get made. So try this one out too. Do your 81 caret key 1 divided by 5. Make sure you're using those parentheses, guys. And see what you get. You should get, oh, I'd get rid of that too. Yep, 2.4. Should be about 2.4. If you aren't getting that, make sure you're asking, and I can show you. We can make sure we get it right. You guys good in that? On the homework, do you think you guys can? If the question asks for it, yeah. Usually yes. Usually yes. All right, you guys good in that? Okay. Irrational exponents. Okay. All right. This, if I were to star anything, highlight, no. This one page has a review of all the exponent rules. So I don't know, star it. However you guys mark it, star it, put a smiley face, frowny face, whatever you guys use, right? But this is the one slide that has all the exponent rules put together. Okay. Besides the fractional power ones. It's a nice little review of exponent rules for you. So now that we know our exponent rules, we can actually solve exponential problems. Not exponential problems, but problems with exponents, right? I do these ahead of time. So we need to get rid of that 5, right? We need to get x by itself. Oh, yeah, I did. How do I get rid of 5? Can I get rid of an exponent? Yeah, I can. I'll rewrite over here so I have more room. What if I take both sides to the 5th power? Can I do that? Yes, right? As long as you do it to both sides, you can solve an equation. So according to my power rules, I multiply those exponents, right? Five times a 5th is 1. And then this I plug in my calculator, and it is 6. Now, in your calculator, if you hit the math button, there's a button that says math. Okay? If you hit the math button, there's a star root symbol, right? If you hit that button, it'll say answer in front or something else. But if I type in 5, that star button, and then I plug in 7776, it should be the same thing, right? Because that's saying I'm taking the 5th root, which is the same thing as the 1/5 power. Whatever way that you feel more comfortable doing the problem is how I do it. Okay? This way is probably the way you were taught at some point in your life, but this is actually probably the more used way. All right, sound good? So on this beast, how am I going to get that 1/3? What can I multiply 1/3 by to get rid of it? Yeah, trace, 3. So if I take both sides to the 3rd, what happens to my 1/3 times 3? I get x. Oh, geez. I didn't do this. Someone help me out. What's 12 to the 3rd? I need to make my 3 subscribers happy. 1728. Oh, sorry. Okay. But what do I do when there's wild numbers up there and I need to get rid of them? I think what's this last example? I think let's just skip it. What do I do to get rid of the wild numbers? Multiply by the reciprocal. So what do I do to both sides of this to get rid of negative 4.1? Take it to the 1 over negative 4.1 power. Take both sides to the negative 1 over 4.1 power. So try that in your calculator. Again, make sure you know how to do it now. Just see, well, if I'm not here on test day. All right, so those cancel, right? Those are going to cancel. I got x is approximately 0.82 when I did it. Okay. Yar and R. How do I get rid of pi besides eating it? Divide by it, right? Pi is a number. So if I'm going to take both to the power of 1 divided by pi. Those are going to cancel, leave me with an x. Because I left no pi. I got 1.87. Yar and R. How would you plug that one? So make sure I would do 7 caret key parentheses 1 divided by, and then you have a pi button on there. Second caret key. It's the blue part, depending on where you're at. And then use the second caret key. Yep, good questions. Isn't it wild that you guys are using calculators that have technology in from the 1980s still? And they've never dropped. I'm gonna probably get sued by Texas. And they've never dropped the price of them, even though the tech is so old they could build them for legitimately like $10. All right, here we go. They got us by a stranglehold. I'm gonna get a call now. And then, what? All right. How do I get rid of a square root, though? Mamma mia, that's a spicy meatball. What do I do to both sides to get rid of it? Well, you might already recognize whenever to get rid of a square root, you square it, right? That should just be something in the back of your head. It comes up a lot. But if I don't recognize it, a square root is a 1/2 power, right? Because if there's no number up there, it's a 2. So I'm going to take both sides to the second power, right? And I get x equals 225. If you can do this, you're going to be able to do this whole unit. Because we're going to be solving exponentials. If you can use your calculator to plug in exponentials, you're going to be okay. So make sure that we can do it now because we're going to be doing it a lot. We're going to watch how much my money exponentially decays based on football scores. All right, can I rewrite that problem as x to the 2/5? Yeah, because that's a 5th root, right? Whatever the root is goes on the bottom. Squared stays on top. Now, what's the reciprocal of 2/5? Is it 2 foots? Huh. Like 2/5? All right, I'm sorry, guys. I'm not all in today. Take both sides to the 5/2 power. Okay. Those cancel. And what's 9 to the 5/2? Try it out. Hey, bros. $243. $243. All right. That's all for 6.0. Year. All right. Let's talk about exponent calculations. We just did it, right? That's why I like transitioning from 6.0 to 6.1. Do you guys want to go over this, or do you feel like we just did that in 6.0? How are you going to calculate these using your calculator? How are you guys going to calculate these? Calculator. Caveat, what should I always do if there's a negative involved? What do you notice is on all these problems? Parentheses, right? If you don't put in the parentheses, you could get the wrong answer half the time, okay? So just get in the habit of your number in parentheses, caret key, parentheses, whatever your exponent is, right? Because then if you make sure and put them both in parentheses, you will always get the correct answer, okay? I'll guarantee it. All right. Did we just see these rules? Yep. They're the same exact rules that were in 6.0. Now this is where it gets new. Exponential function. What is an exponential function? An exponential function, put the fun back into function, is a function where x is in the exponent, okay? Everything we did before is non-exponential. So we're going to switch where the x is, okay? So x has to be an exponent to be an exponential function. That's a lot of x's. So let's go through these. Are these exponential functions? It's probably going to be a homework question with this in it. Where's my x on this one? Is it down or is it up in the exponent? Up. So that's an exponential. Is my x up above or is it down below? Down below. This is not an exponential. Ooh, quick review from a while ago. What kind of function is that? That's a power function, right? That's a power function because x is some power. What about this beast? It is, yeah, that is an exponential, yes. Because the x is up above. Yeah. Now, do you want to prove? I'm going to show you guys why precisely that is because it looks a little bit different. We have a minus 5, right? What does it mean when I subtract an exponent? What am I actually doing? Or I could do it. That's 3 to the 2x times 3 to the negative 5, right? So that's the same thing. You don't have to go through this proof why, but I do want to show you guys why it is. That's 3 to the 2x over 3 to the 5. I'm using my exponent rules, right? That's the same thing as 3 to the 2/5 to the x, right? So you don't have to rewrite them that way, but I'm just proving to you why it's an exponential, right? Even though it's a minus 5, I can use my exponent rules to make it so it's something to the x, okay? You don't have to do that. Just say yes or no. If the x is in the exponent, it's a yes. Now, what if I add like a 2x to it? That's nothing, okay? Like, it needs to just have a power. The x can only be in the power. All right. Evaluate them. Review to the first thing we did. What do? I write down my answers. I did this time. F of 3 means, where do I put 3? In for x, right? Make sure it's 2 being taken to the power on this. No, right? So when you go to plug this in your calculator, you know, it'd be 2 times button. It'll work, right? Parentheses, 2, 2, 2, caret key. That's a triangle, that's not a caret. 3, right? And when you plug that in, you'll get the right answer, which is approximately 2.25. So if you had $2 and you invested it in something with an annual MIP of 4%, you'd have 25 extra cents in 3 years. All right, same thing here. Make sure when you plug it in, you're putting it in the top. Okay? So you're going to make sure your negative's on the caret key. Now think about this. If that was a positive exponent, I don't know if you guys but that's our initial. We're going to talk about that later. Should our number go up or down if it's a negative exponent? It needs to go down, right? So let's make sure we did that right. We got 1.64. That'd be Mr. Terwilliger is making your stock picks. And it's an exponential decay, right? Oopsie doodles. Any questions on those, or do you feel okay? Like, so far, we're pretty much doing a lot of calculator work. Would you all like me to go over this one, or do you feel like you're doing the same thing? You're plugging it into that. Even if I have square root, can I plug a... Well, I guess try this one out. See how it goes. Try it out. We're doing to the square root of 5. So plug it in. See what you get. Why not? Practice. If you want to, put that in parentheses. You don't have to on this one, but if you want to get in the habit of doing it to make sure. Because I got 6.44 when I did it. And see if you got 6.44. Like I said, I know it sounds goofy, but remember, on your test, you aren't being graded for work, right? So if you're plugging things wrong in the calculator, what's going to happen to you? You're going to get them wrong. We're a results-based business. One caveat. Do you have to do any work for this last one? What's anything to the 0 power? 1. If you'd like to see a proof of that, I could do it, but I'm not going to. Now, if I forgot that rule, could I always plug it in and see what happens? Yeah, there's no shame in that. There's no shame in that. There's no shame in checking your work. No. I'm not gonna lie, I probably would. All right, we're almost there. All right, properties of exponentials. You don't have to memorize these, but I just want you to think about some things. Can I plug negatives into a power? Yes, it makes them smaller. Can I plug in positives? Yes. So our domain is unrestricted. But now our range, if I have a pure exponential graph, so if I have like 2 times, okay, that's going to be really basic, 2 to the x. My graph looks like this. Is there any number I can plug into that and get a negative? No, right? Because when I plug in negatives, I get decimals. So my range is always from 0 to infinity. Okay? And I can't touch 0. And just like if it's the opposite way, if it's my investments, a decay, it still can't go negative, right? My money just goes to 0. They won't let me take out loans because of my bad investment history. All right? I'm going to graph these. I want to show you guys something. This is actually a kind of a neat thing. So I'm going to grab Desmos. You can also graph these on your calculator. I just like Desmos more. All right, so we're going to graph 3 to the x, and then 1 divided by 3. Lost my caret to the x. All right. So something I want you to notice when we graph these beasts is how can I recognize the graph of an exponential or like match them up with each other? So a few quick things. The red one, this one's 3 to the x. And this one's 1/3 to the x. Now, if it's a basic exponential, why are they always going to pass through the point 0, 1? No matter what, if it's a basic exponential without an a, without an initial value, what's anything to the 0 power? Power 1, right? The other thing I want you to notice, if there's not a number in front, when I go to 1, it will pass through what my base is. You'll need to know that for the homework. I'll ask you, what's the base of this graph? You go to 1. You go to your 1, and you see what the value is. This one's 3. The base is 3. If it's a decay, it doesn't work that way. If I go to 1, it'll be some fraction, right? So for my you guys don't even know what decay is yet. Well, this is less than 1, right? So I go the opposite way. I go to -1. At -1, what do I pass through? 3. So I know it's 1/3, okay? Because it's going to be a fraction. It goes down. This one I know is a 3 because when I go to 1, it's 3. This one I know is 1/3 because when I go to -1, it's 3. If we're finding the base if a is 1. If a is not 1, we can't do it this way. And we're not going to have to do it that way this year. That's for moving on up. I'll actually, you'd use a regression line for that, which we will talk about, but we will not have to do. All right. So let's look at a graph and see if we can find the base of it based on the graph. First things first. Is b going to be greater than 1 or less than 1 based on this? Is it going up or is it going down? It's going up, right? So it's going to be bigger than 1. So I go to the 1, and what point do I pass through at 1? I have the point 1, 2.5. So what's my b got to be? 2.5. That's going to be my function. So I go to 1. Yar nar. All right, what do I do about this beast? Is b going to be bigger than 1 or less than 1? Less than 1, right? B has got to be less than 1 and greater than 0. It can't be negative. If it's negative, some wonkiness happens. It flips the graph. But, so when I go to 1, could I kind of guess? Like when you go to 1, actually that does look like 1/4, right? Let's verify it. Like I could go to 1 and see that looks like 1/4, but that's going to be a tough guesstimate, right? I wrote it really small too. I'm going to go -1 and see where I cross. 4. That's a lot easier to see. And then I can verify it to see on the other side it's 1/4. I could have done the other one and looked at 1/2.5, but you're not going to recognize that. So now since I know it's going down, it has to be a fraction, right? So it's going to be 1 over something. The something I find by going to that -1. When I went to the -1, it was 4. Okay? Does that make so if it's decay, go to -1. If it's a growth, go to 1. And that'll give you the b. That'll help you out in 2 of the homework questions, I believe. We're actually doing great. The transformations on the graph are the exact same as what we did before. What I mean by that is horizontal shift is going to be something like, ooh, this is good, b to the x minus h, right? That would be right h. A vertical shift is going to look something like b to the x plus something. That would move it up k. You guys remember we did that. It's opposite in the parentheses, same on the thing. To flip across the y-axis, right, would be b to the negative x, right? To flip across the x-axis is negative b to the x. A vertical stretch would be, what letter did we use to multiply? Do we have one? We'll call it, that's a b to the x. Where a, a could be big or small. You know what I mean? Like if a is over 1. I didn't make you guys know if it was a shrink or stretch, right? I just had you to say it was either one or the other. And this would be like b times something a to the k. You're not going to see that a lot. But it's the same rules we had before. Same exact rules, just different function. There's one caveat. There's one thing that makes these unique. Yeah. There's one really special case on these. So, remember our first example I graphed, right? 3 to the x and then 1/3 to the x, right? They were mirror images of each other. They were flips of each other. Why? Like, if this is my base function, what transformation happened? A flip. But my gut tells me that's a that's not a flip. Why is that a flip? We know it is. What do I do? Is there a way I can rewrite this with a base of 3 so it looks like that? What if I make that x a negative? Is 3 to the negative x the same thing as 1 over 3 to the x? That's why it's a flip. Notice before when I wrote down the stretches, I didn't change the b. I put a number in front of the whole equation. If your b changes, you're changing the function, or you need to look for that flip. Okay? So that's why it's a flip over y. Now, did I have to? I knew that also because like 4 to the x and 1/4 to the x are flips of each other over the y-axis. But that's why, because the negative exponent. This one's a lot more straightforward. So I'm doing something to the x, so that's left and right. So -2 tells me I'm going which direction, right or left? Yeah, right 2, right? Because it's opposite. And then what's the +4 telling me? Up 4. Does that ring a bell from back in the days? This is going to come up again. We're going to find our x and y intercept again too sometime. All right? We're actually doing money. We'll stop at story problems. Don't be afraid of these. Honestly, for all the story problems we're going to do this year, the exponentials are the most straightforward. There's no trickiness. They give you every number you need. So when I say story problems, don't freak out on these ones. These ones are, as long as you have the formulas, you just plug them in every time. There's no like, which one's y and which one's x. It is very straightforward. So it'll be okay. E, some people say that E is their favorite number. E is a very important number. On your calculators, you have an E button. Can I borrow this for a second? You guys want to go ahead and try to find your E button? It is second ln. It's on the left-hand side, second ln. You have an E with a caret sign. E is a very special number. E is another one of those irrational numbers that should not be irrational, but it is. It's a limit. I wish I could go into the proof class. Maybe we'll just do proofs next semester about why things are. But make sure you know where E is and make sure you understand it because we are going to use it a lot. Okay? All right. Now the good news is, let's look at the graph E of x and see how it's changing. So our base function's e to the x. That looks like this. It looks like all the exponentials. If I do e to the x plus 3, only my x is being affected, right? That's left, right. If it's plus 3, it's left 3. Okay. All right, we have a minus 2 in the back. That is down 2. The negative is not by the x. It's in front. So that flips us over the... Oh, no, I told you guys something earlier on. Maybe I did. I think I did. I told you guys something wrong on one of the earlier ones. I apologize. If I put a negative in front, it means anytime I plug in a number, it'll be negative in my y-coordinate. I messed up my axis. This is a flip over the y-axis. Earlier, when there was a negative by our x, did I say flip over y? Or did I say flip over x? What? What did I say? Wait, no, I'm right. Jiminy Crickets, what am I doing with my life? I was 100% right. That's your x-axis, guys. I was 100% right. I don't know what I'm doing with my life. I'm very tired. My bad. So I was 100% right before, and now it's 100% right. I'm just trying to confuse you guys. So the negative in front of the entire thing flips over the x-axis. The negative by the x flips over the y. All right, we're good. That will get you through all of 6.0, all of 6.1.